Hello everyone, I am Surat. We are discussing about that the magnetic flux Gauss law of magnetism. So in this lecture we will discussing about that. The first of all, what is the Gauss law? Okay, so we are already we already know about that the Gauss law. We all study in the electrostatic. Okay, so we study Gauss law for electrostatic. We see that for a closed surface represented by the number of lines leaving the surface is equals to the number of lines entering in it. So this is consists what the fact that no net charge is enclosed by the surface. So however in the same figure the closed surface there is a net outward flux since it does not include the net charge or net positive charge. So the situation is radically different for a magnetic field which one continuous and the form of closed loop. So for example the Gaussian surface represented by the by uh, by uh, by the different phenomena we can understood by using this phenomena. So both the case visual demonstrate the number of magnetic field lines leaving the surface is balanced by the number of line entering the net magnetic flux is zero for the both the surface. So this is true for the any closed surface. So I shows you there the what is that we have a use of magnetic field lines to visualize the magnetic field and indicate the stand. So we are now going to count the number of magnetic field line passing through the surface and use the count to determine the magnetic field. So see here. So we are now going to count the number of magnetic field lines passing through the surface and use the count to determine the magnetic fields. So see here, there are the number of lines that are passing through the surface. This is the magnetic fields are there. Okay, so the determine the magnetic field. Due to the we are now going to the count the number of magnetic field line passing through the surface and this count the determine the magnetic fields are there. So see here, the magnetic flux passing through the surface is the number of magnetic field lines that pass through it. Okay, what is that? The magnetic flux passing through the surface is the number of magnetic field lines that pass through it. So because magnetic field lines are drawn arbitrary, we qualify the magnetic flux like this. Phi of m it is equals to b into a, where b it is the magnetic field are there and a is the area of the surface. So this is the magnetic flux is like that. The phi is equals to b into a. So see here, if the surface is tilted, okay, if the surface is tilted, then what is forever the lines cut the surface, okay, line cuts the surface. On that time, the angle is making between the surface line and the fill lines and also the fill lines and the surface. It's making the angle theta between both of them. So on that time, what will happen? So if we define a to be vectors having a magnitude equals to the area of the surface in the directions normal to the surface. So the amount of the surface perpendicular to the magnetic field is a cos theta. Okay, what is that? A cos theta. So therefore, because of A is perpendicular to the surface, the amount of A parallel to the magnetic field is A cos theta. Okay, it is A cos theta. So parallel it is A cos theta. So phi of m it is equals to B into A. It is equals to B A cos theta. And suppose remember that dot product from the physics, phi of m it is equals to B dot A. Now the field if the magnetic field is not uniform in the surface is not that, then if the magnetic field is not uniform or the surface is not flat, on that time what will happen? They divide the surface into the infinitesimal surface element. See here we are just considering the small amount of the surface, infinitesimal surface element, and add the flux through each. So on that time what we will do, the adding to the all the surface and the summation of all this surface. On that time we will get that the summation of that. So infinite divide the surface into the infinitesimal surface element and the number the flux each. Okay, so on that time what we will do, we have distribute in the discrete quantity of this. On that time we will get the total surface element, total magnetic field in the non-uniform surface. So see here, the phi of m it is equals to limit delta I tends to 0. Okay, delta ai tends to 0, b into delta a. So in our book where we are using that the delta as, but here we are using the delta a. So delta bi into delta ai. So on that time what we will get? We will get that the integrations of that integration of phi of m, it is equals to integration of b into dA. What is that? B into dA. So you are starting equations sheet as phi of b, it is equals to integration of b into dA. It, if possible, use is phi of m, it is equals to integration of b into a, it is equals to ba cos theta. Now if surface is closed loop, okay, completely enclosed the volume. So consider then the flux of phi, the calculate the individual flux through each, the then the net flux phi b will be 0. Okay, see here there are the flux will be, maybe it will be 0 because why? The consider small vector, we are considering the delta A closed surface. Okay, the magnetic flux through the A into magnetic flux is defined as the phi of b, it is equals to b into delta A, where b is the field and delta A is the area. So the we divide A into many small area element and calculate the individual flux through it. Then the net flux phi b is that, what is that? Phi of b, phi of m, it is equals to, here we are considering the phi of m. So phi of m, it is equals to summation of phi of m, it is equals to the b into delta A, it is equals to 0, where all the stands for all element area element. Compare this with the Gauss law for electrostatic. The flux through the closed surface in that case is given by, in that case it given by E into delta S, it is equals to Q upon epsilon 0, where Q is the electric charge enclosed by the surface. The difference between Gauss law of the magnetism and that for the electrostatic is a reflection of that fact. The isolated magnetic poles, also called the monopole, so are not known to exist. So there are no source or skins of B. The simplest magnetic element is a dipole or a current loop. All the magnetic phenomena can explain in terms of arrangement of the dipole or the current loop. So the Gauss law for a magnetism, the net magnetic flux through any closed surface is 0. So see here, suppose here we are considering the, if the surface is closed, on that time we count the lines going out at a positive, lines going as a negative. So on that time phi of m, it is equals to integration, close integration of b into dA. Now surface integral, therefore the double integration integrals are there, but there are no magnetic monopoles in a nature. So jury is still out in the 2009 experiment, but the lack of recent development suggests that nothing to see. If there were more flux line going out of then into the volume, so there would be magnetic monopole inside. So therefore the phi of m, it is equals to closed loop integration b into d, it is equals to 0. So Gauss law for this is our Gauss law for a magnetism. So this law any may require modifications if the existence of the magnetic monopole is confirmed. So it is a, whenever what will change, when the magnetic monopole will be confirmed, on that time the law of Manny requires the modifications if the existence of the magnetic monopole is confirmed. So Gauss law of magnetism is not very useful in this course. So the concept of magnetic flux is extremely useful and will be used later. So you have now learned Gauss law for the both the electricity and the magnetism. See here, integration of B into D8 is equals to E into D8 is equals to Q enclosed divided by the epsilon 0, and also whenever the integration of B into D8 is equals to 0. So the equations can be solved, can also be written in differential form, is that delta into E, different delta into E, it is equals to Q upon rho upon epsilon 0, and where delta into B, it is equals to delta dot B, it is a divergence curl of E and curl of, so it is equals to 0. So see here the equations are there. See here there are the divergence of E and divergence of B, and also the curl of E and there are the curl of B. So that's why this is the things are there. So we have just considered it here. So if you can't understand in this lecture, then comment in the comment box. Thank you guys. If any kind of problems, then comment in the comment box and still keep learning and keep studying. Okay. So Thank you guys. Thank you so much.